Good morning, students. We have studied how to prepare salts in the laboratory. There are various methods that you have studied, like direct combination, by displacement reaction, by neutralization, or double decomposition, titration, precipitation, etc. Now, today we are going to discuss the general properties of salts. First and foremost, we are going to deal exclusively with only dilute acids. Whenever you react a bicarbonate or hydrogen carbonate salt with dilute acid, you always get salt, water, and carbon dioxide. For instance, sodium bicarbonate, when reacted with dilute hydrochloric acid, will give you sodium chloride, water, and carbon dioxide. Now, if you take calcium bicarbonate and you react with dilute hydrochloric acid, then the salt produced is calcium chloride, and the other two products are common, that is water and effervescence of carbon dioxide. Similarly, you can take another bicarbonate salt, maybe magnesium bicarbonate, maybe zinc bicarbonate, but the products will remain the same. What are the products? Salt, water, and carbon dioxide. So what is the moral of the story? It is, whenever you react a bicarbonate salt with a dilute acid, you always get salt, water, and carbon dioxide. Similarly, a carbonate salt like sodium carbonate, calcium carbonate, copper carbonate, zinc carbonate, a calcium salt when reacted with dilute acid will always give you salt, water, and carbon dioxide. For instance, you take sodium carbonate or calcium carbonate, you react with dilute hydrochloric acid, the salt produced is, in the case of nitric acid, you get calcium nitrate, water, and carbon dioxide. If you use hydrochloric acid, then you will get calcium chloride, water plus carbon dioxide. Now let us move on to the sulfite salts, Sulphite, okay, that is SO3. Whenever you are using a sulfite salt and reacting with, let's say, a dilute acid like hydrochloric acid or sulfuric acid, you always get salt, water, and a colorless gas which is highly poisonous in nature, and that is sulfur dioxide. So in place of sodium sulfite, I can take, let's say, potassium sulfite, I can take magnesium sulfite. I react with dilute hydrochloric acid or with sulfuric acid. I always get salt, water, and sulfur dioxide. Similarly, ferrous sulfide or iron 2 sulfide, when I react with dilute sulfuric acid, the salt produced is ferrous sulfate and the gas liberated is hydrogen sulfide gas. Now this gas has a very offensive odor. Okay, it has the smell of rotten eggs, hydrogen sulfide gas. Now in place of zinc, in place of iron sulfide, you can also take zinc sulfide. You react with sulfuric acid, you get zinc sulfate plus hydrogen sulfide gas. So you have to remember the main concept, and that is what? Any sulfide salt when reacted with dilute acid will always give you salt and hydrogen sulfide gas. Now let us move on to hydrolysis of salts. What do you understand by the term hydrolysis of salts? Reaction in which salts react with water to form base, that is, it can be alkali also, and an acid. That is a solution which is acidic, alkaline, or neutral in nature, and that is called hydrolysis of salt. Now let us take a look at these reactions. For instance, ammonium hydroxide is a base and it is a base soluble in water. I react with dilute hydrochloric acid. What do I get? Ammonium chloride and water. That means whenever you react a base with an acid, you always get salt and water, which we also call neutralization reaction. Now let us analyze it very carefully. Ammonium hydroxide is a weak alkali, as I told you earlier, and hydrochloric acid is a strong acid. Now what happens when you react a weak alkali with a strong acid? You get ammonium chloride. The salt is ammonium chloride and water is formed. Now what will be the nature of the salt ammonium chloride? Now ammonium chloride is a salt produced from weak alkali and a strong strong acid, so it will be acidic in nature. Similarly, the next reaction, sodium hydroxide solution. Now sodium hydroxide is a strong alkali. When you react with a weak acid such as carbonic acid, the products formed will be sodium carbonate and water. Now sodium carbonate is a salt obtained from a strong alkali and a weak acid. So sodium carbonate will show what kind of properties? Basic properties. Now let us look at the third example. Sodium hydroxide, which is a strong alkali, it reacts with a strong acid like hydrochloric acid. It gives you sodium chloride and water. Now both the acid and the base in this case is strong. Hence the salt produced will be what kind of a salt? Neutral in nature. Okay, sodium chloride. Now hydrolysis of salts. Let's take an example of the first one, ammonium chloride. Ammonium chloride, when dissolved in water, it gives you ammonium hydroxide and hydrochloric acid. You all know that ammonium hydroxide is a weak alkali and the solution will be showing you what kind of pH value? Less than 7. That means it will be acidic in nature. Similarly, sodium bicarbonate when reacted with water will give you a strong alkali like sodium hydroxide and a weak acid, carbonic acid, is formed. Hence, the solution is likely to be alkaline in nature. The third example is sodium carbonate. Excuse me. Sodium carbonate when reacted with water will give you sodium hydroxide and carbonic acid. Now remember, sodium hydroxide is a strong alkali whereas carbonic acid is a weak acid, so the solution will be alkaline in nature. And the last example you see is sodium chloride plus water will give you sodium hydroxide and a strong acid like hydrochloric acid. So the result is a strong base, sodium hydroxide, and the acid formed is also a strong acid. So the solution is likely to be neutral in nature. That means the pH value should be equal to somewhere around 7. Now you have studied in class 9 the general properties of salts. For instance, what is water of crystallization, what is deliquescence, and what is efflorescence. Now let us quickly revise. Water of crystallization, it is the amount of water molecules which enters into a loose chemical combination with one molecule of the substance on crystallization from its aqueous solution. For example, you take copper sulfate copper sulfate pentahydrate, which is also called blue vitriol. The chemical formula is CuSO4.5H2O. So the 5H2O you see is the 5 molecules of water of crystallization associated, okay, with the chemical compound copper sulfate. Similarly, you take a look at Glauber's salt, okay, that is Na2SO4.10H2O. So Glauber's salts contain 10 molecules of water of crystallization. Now, what do you understand by the term deliquescence? Deliquescence, these are substances, okay, which on exposure to air, okay, what happens? It absorbs moisture from the atmosphere, dissolve in it to form a saturated solution. So there is a change in state. Example, ferric chloride, anhydrous calcium chloride, zinc chloride, magnesium chloride, etc. And the last of all is efflorescence. You have studied in class 9 that sodium carbonate decahydrate, which is washing soda, is a efflorescent substance. Now, what do you mean by that? These are hydrated salts which on exposure to the atmosphere lose their water of crystallization partly or completely and change into a powder. It changes from hydrated to anhydrous salt. Is that clear? That brings us to the end of the lesson. Please revise it and learn the equations thoroughly. Thank you.